While standing up here, I have potential energy, and we can quantify that potential energy by using the equation mass times gravity times height. So because I have the potential to fall, I'm said to have potential energy, and that's because of gravity. And you too, my dear viewer, have potential, but unlike me, you have the potential to rise and not to fall. This is the conservation of energy. Hello everybody, my name is Kamis, and if you're new here, I'm a medical student and I make videos related to STEM topics that show up on the MCAT, AP exams, and in your STEM classes more generally. Currently on this channel, I'm focused on explaining physics concepts in an intuitive, simple to understand way, because I do think these concepts are truly intuitive, but unfortunately sometimes physics professors jump straight to applying the math before explaining the concepts intuitively, and therefore physics gets a bad rep of being a complex topic. So let's start by defining our terms. The idea behind conservation of energy is that you can't add or remove, create or destroy energy within a closed system, but rather you can transfer from one form to another. There are many different flavors of energy. There's thermal, chemical, and nuclear. We're specifically going to be focusing on mechanical energy, which comes in two different flavors: potential and kinetic energy. Potential energy is the energy stored within an object due to its position. So because this ball has the potential to be pulled down by gravity, it's said to have an X amount of joules of potential energy stored in it. But how do we quantify the amount of energy stored within an object? Well, we use the equation potential energy equals mass times gravity times height. Notice that these variables are directly proportional with potential energy. This is important to note because sometimes you can answer physics questions, especially multiple choice questions, without doing any math if you understand the relationships between variables. So if you were to double one of these variables, you double potential energy. Likewise, if you were to divide one of them by, say, 3, then you divide potential energy by 3. All right, one quick knowledge check before we move on to kinetic energy. Which ball has more potential energy? A ball that's at the edge of a ramp, a frictionless ramp, that's 1 meter away from the ground vertically, or a ball that's just hanging in the air 1 meter away from the ground. So that was a bit of a trick question. They'll have the same potential energy because recall that potential energy relies on mass times gravity times height, and the same mass, gravity, and height will apply to both balls. It doesn't depend on the angle of a ramp, how steep it is. It's all about the mass of the object and how far it is from the ground. Kinetic energy is the energy of motion. And you can understand this if you look at the equation, which states that kinetic energy equals half mv squared. So if there is no velocity, if that velocity variable were equal to 0, then kinetic energy is necessarily 0. Let's zoom out a bit and focus our attention on mechanical energy more broadly. So remember how I said mechanical energy consists of potential energy and kinetic energy? Well, that means to quantify mechanical energy, just add the potential energy of an object and the kinetic energy, or mgh plus half mv squared. Now I need you to pay very close attention because this right here is the crux of the matter. Mechanical energy will always be conserved in a closed system. A closed system basically means like an object that doesn't have any external forces such as friction or air resistance acting on it. So assuming that's the case, the mechanical energy of this ball will not change. It won't increase or decrease. It may change form, but the total mechanical energy will always be equal. So we can also say mechanical energy initial equals the mechanical energy final. For example, if I'm holding this ball at this height away from the ground, then it'll have a potential energy. Let's assume the potential energy is equal to 10 joules. Well, what's the ball's kinetic energy? Since it's not moving, that's 0. So the total mechanical energy of this ball will be 10 joules. Now, once it starts to move, some of that potential energy will be lost because you're decreasing the height. But at the same time, the kinetic energy is increasing in a way where mechanical energy will always remain 10. So the amount that the potential energy decreases by, the kinetic energy increases by that same amount. So we can further break down our mechanical energy equation and say that mgh initial plus half mv squared initial equals mgh final plus half mv squared final. Let's take an example question to make things clear. So the question states that we have a ball at the edge of a frictionless ramp that's at a 45-degree incline. What will be the velocity of this ball when it reaches halfway down the ramp? The ramp in question has a height of half a meter. So that's not from this point to this point, rather straight from here down to the ground. To solve this problem, you don't need to worry about the angle or how steep the ramp is, or you don't need to use kinematics equations. All you need to consider is potential and kinetic energy. So we're going to use our equation right here. Notice since mass is in every single term on both sides of this equation, we can cross it out. So we're left with gh plus half v squared equals gh plus half v squared. Now let's plug our numbers in. So notice how the initial kinetic energy is 0 because that initial velocity is 0 when the ball is at rest. And then let's solve for velocity. Velocity is going to be the square root of 5, which equals 2.25 meters per second. Also, there is another intuitive way you could have solved this problem. Since we know that the initial potential energy after factoring out that mass variable equaled 5, and since we know that initially the ball was not moving, so kinetic energy was 0, then the total mechanical energy was 5. And well, halfway down the ramp, you've lost half of that potential energy in the form of kinetic energy. So you can say that the kinetic energy will equal, after factoring out the mass, will equal 2.5 meters per second. So 2.5 equals half v squared, multiply both sides by 2, and then take the square root. All right, here are some comprehension questions. Let me know what your answers are in the comment section down below. And here are some important equations that we used in this video. And finally, like and subscribe to see more of my content. I hope this was helpful. Let's have a conversation about conservation. You might say we're gonna converse to conserve. I do this to serve the community. At the end of this video, we're gonna calculate the total T. I'm talking time. Wait, did that just rhyme?